In this lesson, we'll finish big idea number 1 and 2. So what are organic compounds and how are they classified? And how does the structure of a compound determine its properties? We'll complete learning target number 1 by talking about esters and amides. Esters are hydrocarbons with ester functional groups. Again, we've got the name of the functional group matching the name of the family. Don't get confused. An ester functional group is recognized by its spelling COC double bonded O, or cocoa. Sometimes it's spelled backwards, so pay attention in your molecule. They have the general formula R, which represents your parent chain, OOR prime. The R prime represents the carbon chain attached on the other side of the functional group. Esters are classified as carboxylic acid's derivatives. They are often made by reacting a carboxylic acid and an alcohol together. Here is a simple example. If we take methanoic acid and react it with methanol, I have the ingredients to make an ester. I have a C, I have an O, and a C with a double bond. What I can do is remove water from this molecule by adding something like a dehydrating agent, such as sulfuric acid. That's what we used in the lab. This will produce my water as my first product, and because this oxygen lost this bond, it will look for something to bond with. And because the carbon is only bonded to 3 things, it will look for something else to bond with to become stable. So I will join the oxygen and the carbon together to make my ester. Naming esters is a bit different than the other families that we've talked about. Other families, the longest consecutive chain of carbons is the parent. That's not the case with an ester. The part with the C double bonded O is always the parent. You would name that part like a carboxylic acid, but you replace the oic acid suffix with oate to indicate an ester. Make sure you drop the E of the parent. Then you name other alkyl groups attached to the main chain as the prefix. Name the C's attached to the O of the ester as an alkyl group in front of the prefix with no position number or letter. You indicate that this is the carbons on the other side of the ester functional group by leaving a space. Here are some examples. Here's my COC double bonded O ester functional group. The piece of carbons attached to the double bonded O becomes my main chain. Because it's 3 carbons long, I have a prop. They are all single bonded, so this used to be propanoic acid if there was an H here instead of a methyl group. Because they're single bonds, AN, and to indicate it's an ester, I use the suffix oate. To describe the methyl attached on the other side of the ester, I don't use a position number, and I intentionally put a space between the methyl and the propanoate. Pause the video and write the name for molecule B. Here's the answer for molecule B. My main chain is the group of carbons attached to the C double bonded O. That also gives me a side chain here and an ethyl group attached onto my oxygen. Because I have 5 carbons in my parent chain, this gives me the root pent, because they're all single bonds, and because this is an ester, O8. Now I indicate any other side chains attached to the parent. If I number my parent chain this direction, my ethyl group has a position of carbon number 3. And then to indicate the carbons on the other side of the ester, I put an ethyl group out front with no position number and an intentional space between it and the prefix 3-ethyl. So the final name for molecule B is ethyl 3-ethyl pentanoid. Properties of esters. The ester functional group creates 2 dipole-dipoles, which can be used to increase the melting point. Both of these occur on the oxygens. In terms of solubility in water, the double-bonded O's, because they don't have H attached, can accept hydrogen bonds from water. And because there's 2 oxygens, it can accept 2. Now the ester functional group is fairly large. It's 4 atoms big. And then we attach other carbons to them. The molecule gets very large very quickly. Remember the influence of size. When a molecule gets larger, then it becomes less polar overall, and it will reduce the solubility of the compound. Esters with more than 4 carbons hit that barrier, and they are too large to be soluble in water. Other information about esters. Some esters have a pleasant odor and a pleasant taste, so they're used in perfumes, and they're also used in artificial scents and artificial flavorings.